Hello everybody, I'm Johnson. Today I'm going to talk about progressive web app. This is a very high level view of progressive web app. So what is a progressive web app? According to Wikipedia, it's a term to use to denote web application that use the latest web technologies. This definition is a bit abstract because latest web technologies it could be anything. Therefore, I like what Ionic define progressive web app. Ionic said that a web app that uses modern web capabilities to deliver an app-like experience to the users. So the app-like experience is the highlight of this. For my definition is that progressive web app can be applied to any existing web app by adding just a couple of modern web features. And then what it did is that it enhance the user experience. So progressive web app is 10 features of it. So first is a progressive, meaning that you can progressively adding it. Responsive, which is we already start doing all this in our web a few years ago. It worked offline, meaning that even there's no internet, the web app still can be used. App-like, meaning that all kinds of gesture of your native app can be done on your web app. Fresh, meaning that you can get all kinds of fresh content. One of the weakness of native app is that they are not able to get a fresh content, like the theme update, everything. It requires you to re-download your app. Next is that progressive web app is safe because it requires HTTPS as a protocol in order to use it. Discoverable because we add a lot of new meta tags. Re-engageable by using a push notification. Durable, what it means here is that when we transfer across a few web pages, when we close all the existing web pages, the data will be stored instead of being deleted. Linkable is just like typical, like WhatsApp. There's a certain protocol for it. Sorry, it's not protocol. It's WhatsApp. There's a link, so you can just send to a person, and the person can access to link. They will automatically open the WhatsApp. All these feature currently, I can say, is still experimental. A few days ago, Edge and Safari already added the support for service worker. So what is a service worker? Service worker, first I'm going to talk about the caging part of service worker. So I'm talking about the offline support, or how to make it offline support and reduce the memory downloaded from a web page. So this is a service worker. Service worker has a life cycle. So in installing, it's mainly do all those caging related, normally on the static caging. And then next, I'm going to talk about the activating. Activating is a process after installing. What we do here, normally we'll delete the old cages. Fetch event is a replacement for the old kind of Ajax. And then fetch event normally occur when we fetch a new JSON image or fonts. So in fetch event, we can make also a caging. So we call it a dynamic caging. So this is a caging strategy I took out from the offline cookbook. You guys can check out the website. So this is a on install method of strategy. So in the web app, you have an install event to your service worker. So the service worker listen to install event, typical JavaScript, and then in the install event, you save it to the cache, and then you return, and then we'll trigger the activate event. So on install, not as a dependency, meaning that this is a faster way, meaning that you install and you put it into cache and activation at the same time. So it reduces the time of caching. And then the other way is on activate. On activate, as I explained just now, is that we'll delete old caches. So on install event, into our service worker, they listen the install event, we'll create a new cache, version 1.1. And then on activation, you will delete the old cache. Okay. So next is on user interaction. We can cache these things, for example, images, dynamically. So when the user has a click event on our typical JavaScript, we can trigger save the image into the cache. So what my strategy I use in my in my personal website is that I have an install event. Because my personal website has a blog, so I want to have a push notification for my user. So how I enhance this is that I have an install event, and then I'll save it to the cache, and then on activation it'll delete the old cache, and then on dynamic fetch event I will save all the fetch event, for example images, new blog contents. I will save it into a new cache. Alright, so this is a demo on caching. So on caching, normally we'll surf on a website that we never surfed before. So in this sample website, when I use on the Google, I'm using Google Chrome, so I can choose the network, and then I disable the internet, and then when I reload, you see the web pages has no internet connectivity. However, when I connect back the internet, this you'll get back the same web page. This is the behavior that we expect. However, when I went to a web page, they have registered service worker, no matter which strategy it is. So I can just straight away go back the home, and then I force the internet to disconnect. When I refresh, it's still working. You see, it is still working. So basically it's offline, but it's still working. The reason why is that I already cached all this. So I already statically cached the other pages. For example, the notification permission, I already cached it. So basically, even there's no internet, they still. So background sync is what we normally see on a WhatsApp. For example, when we have a very weak internet access, even though we send a message, it won't go fail. Like for example on WhatsApp, when we send a message when we are offline, when you close the app, when we have an internet comes back, then it will still send the message to the person that you want to send. This is what background sync do. All these thing doesn't work on typical HTTP protocol. It only works on HTTPS. So just take note that you need all this, but in localhost for testing, it still work without HTTPS. Next, I'm going to talk about add to home screen. Add to home screen is not a standard way, so you don't use it in production because it still haven't released from. It only works on Chrome. So on Android, it looks something like this. They prompts up something, and then you can add, and then it shows up like that. On iOS, you need to do it manually. So the requirement is the service worker being registered and is served over HTTPS. And then you need to have a manifest.json. Manifest.json is a kind of benchmark. Manifest.json is just like your identity of your web. So it will show us up how the app looks like. And there's a minimum benchmark. The minimum benchmark, I'll talk about it later. So manifest, this is the identity. So you have a name, short name, team name. This is all the meta tags that required by a website to serve out a better look on your phone. So you declare how the app looks like, and then you can do a lot more, like orientation of your web app, your start URL, and all kinds of things. This doesn't just now those only works on Android. So if you want to use it on iOS, you need to add certain meta tag in your HTML file. It also works on IE kind of phone like Windows. So the minimum benchmark is based on time and number of visits. The last time I read through the documentation is 5 minutes each visit, and then you need to visit that website twice. So it automatically prompt up the app to home screen. You can do it manually by using the other approach. So I'm going to show a demo. So this is my iOS on Safari. And this is my Android Nexus 5X. So this is, you see, as I go to a website, so when I go to a website, I can, you see, on the Android there's add to home screen. I can add it and then add automatically. So this everything done is automatically. And then on iOS you need to do it manually. So you click on this button, then there is you need to scroll it. There's add to home screen here, so you add it to the home screen. Add. You see the app is on your home screen. Alright, on your Android it's also added on your home screen. It's here. So when you open it, you see there's a green background because I stated everything in my manifest.json file. Alright, next I'm gonna talk about the push notification. Push notification, it combines two API, notification API and push API. So I'm not talking about Safari push notification today. I'm talking about the Chrome and the Firefox. This is a high level view of how push notification work. So this works when the user accept on how on the notification. I will explain this later. So before we start anything, we need the user to accept for us to send them notification. So in our JavaScript, we prompt up allow push notification, and then the user will send all the user data into our server, and we will save everything into our database. So this is the data we store into our database, and we store a subscription, the endpoint for us to push. For example, this is in Mozilla. So Firefox, we send it to that endpoint using a push protocol that require us to give them a authenticate and P256DH for them to send to the user as a authentication. And then this is a high level view. So the service worker will listen to push event. So when push event triggered is that when the server send the push messages to, for example, Chrome, FCM, Firebase Cloud Messaging, and then they'll trigger a push event into a service worker, and then service worker will generate a push notification. The notification. So when you listen to push event, I'm gonna demo. When you listen to push event, both Mozilla and Chrome will provide the service on the push event, so we don't need to handle that part. It's handled by our browser. Currently only support in Chrome and Firefox. Alright, I'm gonna show you guys an example. So on your iOS, on your Android, so I'm gonna go my push notification here. The real push notification. This phone is already subscribed to it, so I don't need to sub again. So all I need is just to send a message here. On desktop it's easier to demo because I can just disable my notification. Alright, so when I make it to ask by default, when I refresh, they'll ask me to allow the notification again. So you see, so I need to allow it, and then I subscribe to it, to my backend. And then what I did here, I'm gonna say anything, implement push notification, hello, or gonna send them a link, just link to my github.com, my personal GitHub account, Super7. Alright, so when we click on submit, we'll push all this thing to my backend, and then backend will send, and then the backend will send to our front end. So you see, I have the message from here. So they'll redirect me to my GitHub. On the Android, you can see I did receive the push notification about my website. So I can just click it, and then they'll redirect me to the website. So there's a lot more cool stuff that you can do with your website. In payment, it's just released by our Google developers, so it's quite new. So basically what you can do is that you can make payment instead of using like PayPal or all kinds of the other third-party services. So when you click on pay, it will pop up that do you want to pay or something. So I can just add cancel payment. Okay, so case study wise, Flipkart is is an Indian company that do all kinds of e-commerce. So they use progressive web app. They increase their reach and everything. And then Pinterest, they also use progressive web app to reduce their server on fetching all the new event. Forbes is a news company. And then Twitter also has a progressive web app for his light version of Twitter. AliExpress was one of the earliest company that implemented progressive web app, and they increased their sales a lot. And one of the cool thing that I read through is that Tinder itself also use progressive web app. Then they increase the chance of people sliding on the web. So that's all for the talk today.